Problem number 1 on chapter 6, section 3. Um, for this problem, they have three numbers. These three numbers on the population, 2, 3, and 10. It says assume that sample size n equals 2 are randomly selected with replacement from population 2, 3, and 10. So the possible combinations when you have a sample size of 2 out of three numbers are all these combinations. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 combinations. I created this table to show you the possible combinations you might have. You need to find the sample variance for each one of these combinations. This is the formula for the sample variance. Notice that that S square stands for sample variance. This symbol X bar represents the sample mean, and for instance, if you want to find the sample variance of this group 2, 2, this group 2, 2, what you need to do is, first of all, get the sample mean. The sample mean is obtained by adding these two numbers, 2 plus 2, and dividing the result by the number of elements, which in this case you have two elements. So you do 2 plus 2, which is 4, and divided by 2. Okay. Remember, this is 2 plus 2 divided by 2, right? So that's how we obtain the sample mean. And then all we have to do here is follow the formula. The formula says that you gotta take each value, subtract the sample mean, and raise this to the second power, and divide that result by n minus 1. N minus 1, well, n is 2 minus 1, that will be 1. 2 minus 1 is 1. So let's do this. So it's 2, that score, minus the mean, which is 2. Okay, that's the sample mean over 1. The other value is also a 2. So it's 2 minus the sample mean, which is this number, over 1. 2 minus 2 is 0. So we have 0, all this is 0, plus 0, that will be 0. So the sample variance for 2, 2 is 0. Okay, and whenever the elements are the same numbers, whenever the set, like this set, have the same numbers right here, 2, 2. So like, for instance, 3, 3. For instance, this one, 10, 10. When you have the same numbers in the set, the sample variance will be 0. Try to do this operation with these numbers until you will get 0 and 0. That is the sample variance for this little group, 3, 3, and 10, 10. That is 0. And if you do a sample variance for this group 2, 3, for instance, well, first of all, you need to get the mean. The mean, again, is the sum of the values of the elements in the group, 2 plus 3, divided by the number of elements in the group, which is 2. Okay, we have 5 over 2. So we follow that formula again. It will be 2 minus the mean, which is 5 over 2, to the second power. I follow that formula. And then over 1. Again, n minus 1. N is 2. 2 minus 1 is 1. And the next term is 3 minus the mean. 3 minus 5 over 2, which is this numerator, to the second power over 1. Well, we do the operation 2 minus 5 over 2. That's negative 1/2. If you forgot how to add and subtract fractions, okay, you can actually type it on the calculator to type 2 minus 5 over 2 and they'll give you the calculator returns uh, the resulting decimal number, but you type math 1, and that converts that decimal number into a fraction, negative 1/2. Right? 3 minus 5 over 2, 3 minus 5 over 2, that is again 0.5. You type math 1, and that converts this 0.5 in a fraction. Okay, so that is in case you forgot how to handle fractions. 1/2, negative 1/2 to the second power is 1/4. Remember that when you raise, for instance here, one number, one fraction to the second power, you multiply negative times negative is positive, right? And 1 times 1 is 1, 2 times 2 is 4. That's how you raise a fraction to the second power. If you want to do it here on the calculator, you need to open a parenthesis, a set of parentheses, and type negative 1/2 and raise that to the second power. If you don't type the parentheses, you get something else. 0.25 math fraction, and that is 1 over 4. So that's why we have this number right here, 1 over 4. This is again 1 over 4, which is equal to 1/2, which is equal to 0.5. Notice how I write this 0.5 for 2 and 3, but also this 0.5 corresponds to the set of 3, 2. Okay, that sample, that set, has actually the same sample variance as 2, 3. And these 2, 2, 3, and 3, 2, they have the same sample variance. Okay. Let's continue with the set of 2, 10. So we have this little set, the mean. Did this line too long? It's just like that. Is 11 over 2. Again, how to get this 11 over 2 is 2 plus 10 divided by 2. That is it's actually 12, right? 12 over 2, which is 6, right? Let me correct these numbers right here. That is 6 and 6. Okay, and let me correct this part. I did it wrong, but okay. That's 2 plus 10 is 12. 12 divided by 2 is 6. So again, I follow that formula. It's x minus x bar. So 2 minus the mean. The mean is 6. 2 minus 6. And over n minus 1, which is 1. The next term is 10 minus the mean, which is 6, over 1. Okay? Well, of course, this raised to the second power. I follow the formula. 2 minus 6 is 4 to the second power. 10 minus 6 is 4. Actually, this is negative 4. Okay, it's 2 minus 6 is negative 4. I'm sorry. Okay, to the second power. Okay, that will be 16, or it's positive 16, and this is positive 16, which is the 32. So that number goes here. 32. That number goes also for 2 tenths. That's 32. Okay. Let me continue doing the last combination, which is 310. Okay, let me do 310. The sample variance for 310. I need to find the mean again. First of all, the mean will be 3 plus 10 is 13. 13 divided by 2, divided by the number of elements. That will be 3 minus the mean, which is 3 minus 13 over 2 uh, and over 1. Again, n minus 1, which is n is 2, right? For every single set, n equals 2. N is the number of elements you have in the set. You have only 2 elements. The next number is 10 minus the mean, which is 13 over 2 and over 1. Okay, so 3 minus 13 over 2 is negative 7. Negative 7 over 2, that is to the second power, minus, I'm sorry, it's plus. Plus 10 minus 13 over 2, that will be 7 over 2, again, to the second power. This is 49. Remember that when you raise 7 over 2, you raise the 7, which is 49, and you raise the 2. You raise numerator as well as the denominator, and negative by negative is positive. That will be also 49 by 4, which is 98 over 4. You can also verify these operations I did on the calculator. Like you can actually type negative 7 over 2 to the second power and math 1. That's how I got the 49 over 4. You can verify this operation if you want. Parenthesis 3 minus 13 over 2 in second power, and then press math 1, and that's how I got this number again, right? You can verify all this operation in calculator. 98 by 4, in this case that will be 24.5. Okay, so that is that this number goes here, 24.5 and 24.5. Okay, let's go back to that first page. Okay, so these are all the sample variances we have. As you can, if you count the number of squares in this table, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's see. Let's fill out this table right here. How many zeros do we have out of 9? We have 3 zeros out of 9 elements. How many 0.5 do you have out of 9? You have only 2, 1, 2 out of 9. How many 24.5 do you have out of the 9 combinations right here? You have 2 over 9. We have 2, right? 2 24.5 out of the 9. And how many 32s? Again, you have 2 32s out of 9. That's how we got this number right here. Okay? The